Hi everyone. So for this question, they ask us to solve modulus. Alright, so when you see modulus, inequalities, and another side here is 2 over x rational. So we come to the notes here first, absolute inequalities. What can we have? We have basic definition. If you have less than, it will be definition as n. If you have more than, you will need to use your definition in all so that you can open your modulus, define your modulus. One is positive function, one is negative function. Alright? And we only have special case when you have both side modulus. This question, can we apply this both side modulus? Cannot, yeah? Because only both side modulus, only we can square both side. Can we square both side? Cannot. So one side modulus, one side don't have, we cannot. We just can do definition. So open this modulus accordingly. So basic definition to open this modulus. One modulus open, it will be positive sign. Another one will be negative sign. So when negative function, you need to change sign when you multiply it negative. And what is our definition here? If you have less than, means our definition here will be n. So what does this indicate here? Which means that we need to solve this positive function. We solve until the end. Then modulus also will have another negative function. We solve until the end. So both answer we need to end. We need to overlap to conclude up into one answer. Alright, combine back to be one answer. Alright, so look at the inequalities we have. When we open modulus, we're no longer getting modulus form. It is inequalities. This is what? So can we just cross this? X multiply to the left. Can we cross multiply? So as we understand here, X cannot cross multiply. Tak boleh darab silang. Tak boleh ambil belah kiri, darab ke belah kanan. Tak boleh ambil kanan, pergi darab, pergi kiri. So cannot doing cross multiply. In what? In the term of fraction. Once you see pecahan macam ni, X is in the denominator, x is in the power of negative 1, x is in the power of negative 1. These guys, this term. So which means that you are in the concept of rational and in the symbol of inequalities. So what can we do? Alright, so move everything to the left, let your right hand side 0, get same to the denominator, simplify. So x plus 1 minus 2 over x less than 0. Then get same to the denominator, means this denominator times x. Dia pun darab x become x squared. This one times x. So get 0. So I get same to the denominator already. What can we do? We simplify into the factorized form. Alright, this is not considered quadratic. This is still considered irrational. We can see quadratic here. Can we factorize? We factorize it. So you bear in mind, you simplify here have to until the factorized form. So try to factorize these inequalities, this quadratic here. Plus, minus. Alright, so after we factorize, then only you can see by solve this by using positive number line. So right method to solve these rational inequalities is positive number line, letting all the factor. So you bear in mind, see, all the factor, not all the equation, not all the denominator or numerator. Numerator here got 2 factor. So let one by one to be positive. Let another factor to be positive. Let the denominator to be positive but not equal 0. So that is what we mean in this note. Let the factor positive, the factor, alright? Not letting all the numerator positive. Bukan let macam ini. Not like this. This is not letting it positive. You must let it one by one term, one factor by one factor. So we have 3 things here. Alright, so our positive number line simplify, you get 1, you get -2. This one already simplified. So we have 3 layer. So we have 3 factor, 3 layer, 2 from the numerator, 1 from the denominator. Arrange the number in order. Start from -2, 0 and 1. Then we start drawing this one. More than equal 1, greater than it. So in the meanwhile, you draw and at the same time we put in the sign so that we didn't confuse. Then second number line, more than equal, drag it to the right. So this is positive, positive, positive. This part don't have line, negative. So draw one, put in down the sign one by one. So this one, more than 0, positive, positive, negative, negative. So combine back. Hasil darab balik. Darabkan dua numerator dengan denominator. Darabkan dua numerator dengan denominator. Multiply it, all these numerator and denominator become negative. Positive, negative, negative, positive. So this is negative, this is positive. So lastly, when you multiply off the numerator and denominator, lastly, what do you need is negative value, negative region. So our answer will be fall in negative infinity until -2 included. Continue, this region will be 0 to 1, close bracket. Alright, then we done. We simplify, we select the region, means we get the answer for this rational. So for this pecahan inequalities, we already done. Now we proceed to another side, which is the negative function one. Masukkan, buka modulus, satu positif, satu negatif. So sekarang kita selesai yang part yang ada negatif yang dah tukar sign. Okay, so bear in mind, jangan darabkan X. Darabkan X, jangan jadi darabkan dari kanan ke kiri, salah. Just rearrange only. Plus 2 over X more than 0. And then everything 2 in the left hand side. Samakan penyebut, darab X jadi X square. Darab X jadi X. So this one already have penyebut X, just value 2. And we try to factorize, alright? Move to the left, equal the denominator, simplify, factorize. So can we factorize this? We can try to press your calculator. Can we factorize this quadratic? I not think this quadratic can be factorized. When we getting equation, you get polynomial, you get the degree of 2, your A is 1, your X is 1, your C is 2. You will notice that it gives you a complex number. What does it mean? Complex number. So it don't have roots. It don't have factors. So this part, what can we say for this part? So we will come to the part of analytical method. So this part. Even though it cannot factorize. Okay, let us see, revise back analytical method. Analytical method means in some part of the denominator or denominator, it can obviously, we know that no matter what value of X put in, it will keep on just positive or just keep on just negative only. So when you have a quadratic without roots, just imagine quadratic without roots, what does it mean? It will be above the x-axis. Above the x-axis, which means that for whatever value, or I can say for all value of X, it will give you X squared plus X plus 2 is always positive. Whatever. Whatever value of x you put in, you can try, you put in negative, you get positive, you put in positive, you get positive, because you can see in your graph it is above x-axis, means your whole graph is always positive. So this quadratic, when it is always positive, we definitely know that this characteristic from here is always positive. What to do for the denominator with this value of x so that the whole fraction give you positive? So denominator we don't know. Denominator is x. X it will be depend. If you put in positive value, denominator positive. If you put in negative value, your denominator negative. So your denominator is unknown. It can be positive, it can be negative. We cannot identify what is the value that can make the positive. But at numerator, we confirm for all value of x, it always positive. So in this case, like this, if your numerator is positive, your denominator you don't know. To make your fraction to be negative, your denominator have to become a negative properties. Then only you can find out the region that as long as you give the x more than 1, you will give your fraction negative. Alright, so this is how we do for analytical method. So since this numerator always positive, so it gives the impact on, therefore for denominator yang tak tentu, is uncertain with the properties, your x here have to become what kind of characteristic so that you can get positive. So positive over what to get positive? We get positive, so positive over positive. So therefore, your denominator have to become positive. So we not take it equal because denominator cannot equal to 0. Alright, therefore your x will be need to equal to 0. That's all. You can get the value of x that make this fraction positive. So I have two answers here. One is this, another is this. Therefore, to combine, okay, to combine this, and which means that this number line will going to intersect with this number line. So the number line here will have, the number that I have here is -2, 0, and 1. So from answer from the left hand side, I get -2 less than it, and then 0 until 1 included. This is left hand side answer. And from the right hand side answer, I get more than 0. So left hand side answer and right hand side answer, both answer we conclude out to be one answer. Intersection happen. Obviously, this region only have one line, no overlapping happen, no intersection. This also no line, so don't have any intersection. I can see intersection happen here. So this is the area that intersect until 1 only. After 1, this part don't have line, so it don't have any intersection. So after this intersection, we can conclude out the answer will be 0 until 1. So I write it in interval form. Alright, so I want to review something here where I get a mistake here when I doing letting. Alright, so when the question don't have equal, we don't let this. We just more than equal. We just more than, not equal. We don't have more, we don't have equal here because our question not equal to 0. We cannot just equal. Alright, so I need to do some correction on this. This supposed to be empty circle. This supposed to be empty circle. So okay, just more than only, not equal. Our question don't have equal, so don't put equal. Our question got equal, then we consider to put in or not. Denominator confirm don't have lah. Okay, so I review. The answer here is open bracket. This is open bracket. So when I come to this part, it's supposed to be empty circle. empty circle, empty circle. And alright, so when we do it in the set, of course, if you have empty circle, you will not included. When you have one of these empty circle, the value 1 here is not included because one of them is not included. Combine back together in the set, one does not exist, so we cannot exist. It will not exist in the answer. So this is interval form. We put it in set, it will be 0 in between x, in between 1. So that will be our set solution. Alright, so I think that's all for this. Thank you for watching.